He kōna e purangi tēnei nā te reo irirangi o Aotearoa.
They say life is stranger than fiction.
And this rover includes a toaster-sized electrochemical cell that is called MOXIE. MOXIE stands for Mars Oxygen In Situ Resource Utilization Experiment.
But sometimes what we see in movies or read in books is so incredible that it obviously couldn't be possible. Or could it?
A 1 cubic meter MOXIE will be about 1 ton, and it could produce about 10 kilowatts of power. And they said that will probably be enough for human exploration.
I'm Brian Crump, and welcome to Sci Fi, Sci Fact. This is a podcast where we take science fiction's strangest ideas and explore if they actually could happen. Maybe they already have. Here to tease out the fact from the fantasy is Samuel Martin Torresinho. He's a PhD candidate with Canterbury University, working in the lab of McDiarmid researcher Aaron Marshall.
Welcome to the Mars Federal Colony. For your safety and comfort, domes have been installed to protect you from the vacuum outside. Please do not touch exterior windows or airlocks.
So how long do you plan to stay on Mars?
2 weeks.
Have you brought any fruits or vegetables onto the planet?
2 weeks.
Excuse me?
2 weeks. 2 weeks.
That's Quay.
Where?
The woman. Get him. Her.
Arrest that woman!
Get that woman. Grab her.
Back up these people! Clear!
Catch.
Get ready for a surprise!
Ah, yes. Total Recall, one of my favourite movies when I was in my, must have been early 20s. Science fiction, what it is. But, I didn't really think much about the science in Total Recall. It was more the action. I remember that there was a mining operation on Mars and they all had to live underground because they went above ground and they didn't have some kind of spacesuit on. Their eyes would pop out of their heads because of the lack of air pressure. And they were mining something, I think, called Turbinium. I can't remember why, but I do remember at the end of the movie there was this big explosion, as there often is in an Arnie movie, and Arnie was outside and his eyes were starting to pop out of his head because he was above ground, but the explosion released all this gas, and in a matter of moments, the Martian air became breathable and they all lived happily ever after. How was that for a really, really, really rough plot summary?
That was, I think, very enlightening, I tell you that. And great pronunciation as well.
It is Turbinium, which was the mineral. That was the plot device.
Turbinium, yes.
Turbinium.
Yeah. We don't know much more apart from what you just said, though.
Really? We don't know why they were mining it?
Yes, not really. So Turbinium is pretty much a plot device. Similar to unobtainium in Avatar.
Yeah.
Turbinium is the only reason why humans go to this planet, in this case Mars, to mine it.
And they live underground.
Yeah, they live inside of whatever
they were. They never went above because, like I said, their heads would explode. They couldn't breathe, and the air pressure was so low they just pop. And that was quite a good special effect. But now, who wrote the story? It was based on a short story, wasn't it?
Yes, it was. It was based on a short story called "We Can Remember It for You Wholesale," and it was written by a US-based science fiction writer called Philip Dick. And he's probably more familiar to you than you think, because behind his pen, they have come a lot of movies that have made it to Hollywood, such as Blade Runner.
Yeah. So he wrote Do Androids Dream of Electric Sheep?
Correct.
I think that was the name of the short story that Blade Runner was based on. And off air, you were telling me about at least one other that I've been to.
Yeah, so The Man in the High Castle.
Yeah.
That Amazon TV show. He's also based on one of his short novels.
And Minority Report, that was a Tom Cruise number.
Yes,
That's one of his
also
as
based.
well?
Yeah, he was quite prolific.
Yeah, so he's got a great imagination, and that's great science fiction. All of those were great science fiction topics. But, you know, now the German director, what was his name? Paul Verhoeven.
Yeah.
He turned it into an Arnold Schwarzenegger and Sharon Stone action flick, which it was. It certainly succeeded. But the thing is, Turbinium, we don't really know much about it, so we can't really talk about that apart from it plays a role at the end of the movie because it's the turbinium exploding that creates the gas that comes out into the atmosphere and makes the Martian air breathable and the air pressure heavy enough that your eyes don't pop out of your head.
Correct. So the turbinium was used to, or was part of the action that terraform Mars. Terraform is normally understood as whatever action leads to a planet resembling more to Earth, making more habitable.
Somewhere we can live in without having to wear a spacesuit, ideally.
And I honestly think it's a great thing that turbinium is not explained more and it's also not real. Because I want to tell you one thing, Brian. I think it's about time that we humans start looking for other planets and future elements to solve our own problems. I think it's about time that we think about what can we do with the materials that we have and how we repurpose them in order to achieve whatever we need to.
What, on another planet or just make the most of life on this one, Samuel?
I think both options, Brian. And that's why I wanted to tell you about some technology that is underway at the moment that is looking into, well, not terraforming Mars, but potentially obtaining oxygen in Mars.
Yeah. Now, actually, there was a news item, and you reminded me of this before we went on air. There was a news item about one of the missions on Mars. I don't know which one. I'm sorry. Maybe you can tell us. But where they managed to manufacture a little bit of oxygen.
We have landed Perseverance, in Mars. And this rover includes a toaster-size electrochemical cell that is called MOXIE. MOXIE stands for Mars Oxygen in Situ Resource Utilization Experiment.
Oh, yeah, fantastic. And how do you make, so because most of, a couple of things about Mars. First off, the atmosphere is very thin.
Yes, about 1%.
So if we were actually, if we could just go right now, stand on Mars, and if I wave my arms around, would I even feel, you know, I'm waving my arms around right now and I can feel the air rushing past my hand. That's the air pressure. If I did that in Mars, would I feel anything?
Well, it's not only that, it's only that the gravity is also less than in Earth.
Yeah, yeah.
So, yeah, I guess it will be quite different.
But it's mostly carbon dioxide?
About 96%, really. Only 0.1% oxygen. So,
okay.
So that's a considerable difference.
So MOXIE, how did it make the oxygen? How did it get the oxygen out of the air?
So, similar to what a tree does, basically. So they use a compressor to pull the atmosphere, in this case the CO2, inside of this equipment, and there it goes through electrochemical process, which basically what it does is it strips oxygen from the CO2 in the atmosphere.
Right. So it's taking what? It's taking O2 from the CO2?
Yes, it's taking,
And so it's left behind, you have a bit of carbon left behind?
Yeah, CO, carbon monoxide.
Well, just carbon. So it takes what, one O from the carbon. So are you left with a molecule of O1? But does that become an O2 molecule?
Yes. So that's part of the electrochemical process. Yeah, you strip the molecules that then they oxidize into.
So you've got some waste of carbon monoxide.
Yes.
Well, you've got some oxygen, O2. Right. Next question is, how much oxygen did the MOXIE actually make? Yeah,
so this was an experiment. They were testing out the setup, but it produced in 1 hour about 6 grams. And that, to give you an idea, is what you need to keep a dog alive. Sadly, not a person.
a dog alive?
A small dog.
A small dog alive for how long?
For an hour.
For an hour. 1 hour. For a chihuahua.
For a chihuahua. Probably,
1 hour, 1 hour's oxygen for a chihuahua. Okay, well, How much? And that was how much? How long did that take to produce 1 hour? 6 grams.
6 grams was 1 hour of operation.
1 hour operation.
Yeah, 6 grams. Mhm.
Okay. So
it was quite successful.
Yeah, that's if you could enlarge that.
Yeah.
It seems to me like you could produce enough oxygen to keep a human going for indefinitely, because there's plenty of CO2 to make oxygen out of.
Well, you will need a bigger stack, and you will need to crank up the size of this equipment. But do you know really what they wanted to produce oxygen for? It was not for human consumption.
Well, obviously there's no humans there at the moment.
But the point making there was for the propeller, actually, for the rocket propeller, because when you are launching, you use the rocket fuel, but you also use a lot of oxygen as an oxidant for that. So what they were intending, or the intention is to avoid having to carry that oxygen for when you have to come back to Earth, basically. If you can produce it there, then you take a lot of launch mass out of the way, which will be quite useful.
Is this the same mission that had the little helicopter that was flying?
Yes, very recently happened.
But that wasn't using the oxygen, that was just using blades that were able to create enough a lift to get up into the air in this really, really thin atmosphere.
Yeah, they use solar panels. That was an achievement because the lack of the smaller pressure on the atmosphere and the lack of the smaller gravity as well is an issue when flying. So it was actually the first flight, full propel and full power, outside of the Earth ever done. So
yes, so they've been doing a lot of firsts.
A big achievement indeed, yeah. A lot of firsts. It's been quite successful.
What about the energy needed to do that work, creating that 6 grams of O2 from the CO2?
That's a very good question. So the reaction happens at 800 degrees Celsius. So they have to produce heat in order to run this reaction.
That's a lot of heat.
Yes, it's a considerable amount of heat.
You said it was toaster size.
It's a toaster size, yes.
Now it is a toaster.
It is a toaster.
That's a very hot toaster.
It's a very hot toaster indeed. And the energy, how they obtain it, is from radioactive decay. They actually use plutonium and plutonium.
So it's another one of those, because they power themselves up with a little bit of heat made that's from the decay of plutonium, which then I think charges a battery, and that gives them enough electricity to do what they need to do. So it's the same principle here.
Yes, same principle. Because previous missions use solar energy, but that's quite an issue in Mars, because that thinner atmosphere actually make it more vulnerable to the pressure from solar wind, and then you get these massive solar storms that influence actually.
Really?
Yeah. So the solar storms in Mars actually form kind of like a cloud, right? So you have less access to that sun energy.
That's kind of ironic. So because Mars doesn't have a magnetic field like Earth, because
a smaller one.
Because it's got a it doesn't have a molten core. I think that's my understanding, and therefore it hasn't got the protection of a magnetic field from solar radiation the way that we do.
Yeah.
So actually, it's more, despite being much further away from the sun than the Earth is, solar winds are more damaging there.
Yeah, I think it's the lack of that atmosphere, that protection, and also the fact as well of you're very exposed then in your mission to that ability of obtain that sun. So if you go into a cave, or if the robot is to tip or tilt and you don't have that access, then it's kind of mission over.
Yeah.
So they went for this.
Is it possible you could use these solar flares and the energy that comes from them, if you could somehow... Well, okay, 2 questions actually. First, does those solar flares and solar winds, would they damage solar panels? Do you know?
Mechanically, probably, I could imagine. The integrity of the material could be damaged.
Right.
I don't know how vigorous it will be in that case.
And secondly, but if we built the right kind of solar panel, could it actually utilize the energy? Because if I'm right, the solar flares has actually been more of a release of energy from the sun, hasn't there, which we could potentially convert into something we could harness. Yes.
Solar is indeed being used still in this mission. So that helicopter use solar panels. It's more that it's less, let's put it that way, it's less reliable. If you use radioactive decay, you are sure that you're going to be able to obtain the energy that you need. While in solar sun, you're more depending on other factors. let's do that.
Okay. Well, let's back from the 6 grams for the Chihuahua and for fueling a rocket that might one day blast the little Mars mission back into Earth, into orbit and back to Earth. Making enough oxygen to keep, say, just a group of humans going permanently, like if they could stay there, if lack of oxygen would not be a problem. There might be other problems about staying on Mars, but not oxygen.
Yeah.
What would you need in terms of plutonium to maybe create enough energy to get that 800-degree toaster cooking enough oxygen for us humans?
Well,
say half a dozen.
That's a very good question, Brian, and I am not sure if I can fully answer that question yet, but I can tell you one thing that I look up, and they were mentioning that with the current setup, so using this MOXIE experiment, a 1 cube meter MOXIE will be about 1 ton, and it could produce about 10 kilowatts of power. And they said that will probably be enough for human exploration, that continuous production of it. But to give you a couple of numbers about the magnitude of oxygen that we will need, launching 4 astronauts off the Martian surface will require about 7,000 kilograms of rocket fuel and about 25,000 kilograms of oxygen. So
now, that doesn't mean much to me.
Those are.
Could you compare that to, say, what's used to get a shuttle, one of the latest shuttles up there? I forget the name of the new rocket launcher. Or even, say, the Saturn V that got the people off to the moon. Is that a huge amount of oxygen compared to what they were using?
Well, I will have to get back to you on that one because I don't have the numbers on top of my head. But if you compare it to the 6 grams that were produced just recently to the 25,000 kilograms, it's a big gap to fill.
Yeah.
So there is room for a lot of...
We've still got to use a lot of oxygen and energy to get that thing to Mars so it then can manufacture oxygen from the Martian atmosphere that we can then breathe. The other thing that I was thinking about, and going back to Total Recall, is would it be possible ever to actually release enough gas? Say if the chemical reaction that Turbinium created, or whatever it was doing when inside the beneath the Martian surface. Could you ever release, how much gas would you have to release for the air pressure and the air to become breathable on a planet? Mars is smaller than Earth, but still, it's a planet. In order for Arnie's eyes, because, they had about a minute to hold on, It took about 60, maybe 90 seconds, and Arnie's eyes didn't pop, and he got the air he needed to breathe. Like, that, to actually fill up an atmosphere on Mars with how much gas? I mean, wouldn't the amount of gas that's coming out be so massive that it would split the planet open?
Well, that's again a very good question. There's a couple of points there. One, the atmosphere is not very dense, so we will have to, first of all, to make it breathable, is to enrich the atmosphere a lot to make it more dense for us to be of any use. And that will not happen in a minute.
No.
That will require time, a lot of time. So the first...
You'd probably require hundreds of years, wouldn't it?
Absolutely,
even if we really had
even more.
Yeah.
The only thing that is true about that sequence is that they melt the ice in Mars to produce that water, right? And that's the only true thing in that sequence, that most of the water in Mars is ice.
Frozen.
It's frozen.
Because Mars is very, very cold.
Minus 63 degrees on average.
On average?
Yeah,
Celsius?
Yeah, Celsius, compared to 14 degrees, that is the average temperature on Earth. So, yeah, if we wanted to terraform Mars, you will want it once to make a more compatible atmosphere, and the other one to bump up that temperature.
Because this is the thing: if we had more air and more water, the water would just freeze anyway, wouldn't it? It'd be mostly frozen most of the time.
It would be mostly frozen. Yeah.
And that's no good.
Yeah, no, we need to increase
water
the
needs to
temperature.
be liquid for us humans and most other life to kick around, right?
Unless you can survive out of ice creams, I think, yeah. But funny enough, one of the theories that I read about that they were planning to how to increase the temperature in Mars was to actually use mirrors, mirrors reflecting light into the. This was more, I think, kind of like a blue sky kind of concept.
Yes.
But the reality is that Perseverance, the rover that is now in Mars, went from like blue skies kind of concept to a reality in 6 years. So maybe it's a matter of putting our hearts into it.
As you said, most of the air on Mars is carbon dioxide.
Yeah,
Doesn't that mean that if we can keep that, wouldn't Mars be great greenhouse effect? And why isn't there a greenhouse effect anyway? Or is there actually? But it's still bloody cold despite the greenhouse effect.
It's not that dense. That's the other issue, right? So you don't get the same greenhouse effect. You have to get it much more compressed.
We'd need a lot of carbon dioxide as well as oxygen in there. Do we need nitrogen to create sufficient density for it to be livable, even though we don't need nitrogen to breathe? But would you need to have nitrogen there to give it a sufficient bulk, the atmosphere?
Or that could be one of the options for sure, to make it more compatible with air, to have like more nitrogen and oxygen.
Except how do we get the nitrogen there?
That's a very good question. If you have me here any other day, I can look that up and get back to you on that one.
Yeah, because I don't know where you get the nitrogen from.
Yeah, that's there are bacteria that can produce nitrogen. That could be one of the things. Algae that consume CO2. They could be a reaction producing other greenhouse effect like methane, and that. There are probably different possibilities to get us out there to that transformation. But there are definitely other technologies that are more at our fingertips right now that could help us to achieve that terraforming of Mars. And another one that I wanted to mention to you was one that I'm quite familiar with, because it's the one that I've been using in my PhD, and it's called, another acronym, MOE, and that's molten oxide electrolysis.
Molten
oxide electrolysis.
MOE.
So, yes. So this was also pioneered by NASA. What it really means, MOE, is you are electrolyzing. So electrolysis is to use electricity, to use electrons to create a separation, a lysis. And what you're separating here is the oxygen from the metal on metal oxides that have to be molten. That's why it's molten oxide electrolysis. And what are metal oxides? Well, metal oxides are most of our minerals.
Yes, iron oxide, for example.
Oxide, for example, calcium oxide, silica, titania. So if you think...
Why is that related to terraforming Mars?
Because imagine that we do this in Mars. You get the regolith in Mars, all the rocks, and you melt them, take them to a certain temperature, and then you could potentially, using electrolysis, separate the metal from the oxygen in this rock. So you will be able to evolve oxygen and to melt and to produce metal that you could be used also to construct or to...
What are the main metals on Mars?
Yeah, so the main metals on Mars are actually quite similar, the main elements to the ones in Earth. So you have silicon, calcium, aluminum, magnesium, oxygen.
But not turbinium.
No, not that I've been aware of.
Turbinium. I think I've been saying it. Turbinium. Or turbinium.
Turbinium.
We're getting there. We're
getting there little by little.
That thing in Total Recall. The other thing about the atmosphere here on Earth is, I mean, it's a result of. It's not just like the Goldilocks atmosphere that we have now. It didn't just happen. It happened because of life, didn't it?
Yes.
It used to be much more. Life used to use CO2, and oxygen was a waste product of early life. And the early life had to evolve then to survive the great oxygen extinction period, I think. And only our ancestors survived this oxygen and evolved to live in an oxygenated atmosphere, right? And that took millions of years, billions of years.
Starting with algae that consume the CO2 and produce oxygen, life coming out of the water. Yeah, that will definitely not happen in a minute. So our friend Arnie will be Not capable to flex anymore.
Yeah. I'll be back. I've been waiting a long time.
Indeed.
Thanks for listening to this episode of Sci Fi, Sci Fact, hosted by me, Brian Crump, produced by Andrew Robertson, and of course, made possible thanks to the incredible knowledge of those brilliant scientists at the MacDiarmid Institute. You can find more episodes of Sci Fi, Sci Fact on the RNZ podcast page. RNZ's podcasts are also available on Apple Podcasts, Spotify and iHeartRadio, or pretty much wherever you find your podcasts. And make sure to follow us so you don't miss out on any new episodes.